Hi guys, in the previous lecture we have seen the basic of transient, in which we have covered the response of RL and RC network, how it will behave in transient state and at steady state. So we have seen the graph of RL, that is the charging and discharging of inductor circuit and the capacitor circuit. After that we have learned some important point to remember, like at t is equal to 0 plus how the inductor will behave, at t is equal to infinite how the inductor will behave, similarly at t is equal to 0 plus how the capacitor will behave, and at t is equal to infinite how the capacitor will behave. We have seen all these things in previous lecture. So in today's lecture we will be covering transient in DC, in which we will see some problem based on source free RL circuit. Okay, we have already studied about the charging and discharging of RL circuit and how it will behave in transient state and steady state in the previous lecture. So if you guys are having any problem in theory, then you may refer to the previous lecture. In this lecture we will be discussing only the questions, and whatever I am using the concept in solving the question, that has been discussed in previous lecture. So it's important to watch the previous lecture. So please watch the previous lecture, then proceed to lecture number 13. Okay, well, I divided the DC transient in three categories. First one is the source free circuit. In all the source free circuit, the inductor and capacitor will lose its stored energy to the resistor. So at the steady state, the energy present in the network will be equal to 0. In all the source free circuit for t less than 0, the network is at steady state, and what we are doing, we are removing the source voltage, that is the input voltage, at t is equal to 0, and we will see the response of RL circuit, RC circuit and RLC circuit without source for t greater than 0. Got it? So in this case, the inductor and the capacitor will lose its stored energy to the resistor, and at a steady state the energy present in the network will be 0. Okay, in second categories I put those circuit in which source is already connected, and we are dealing only with two conditions, that is at t is equal to 0 plus and at t is equal to infinite. What will happen in RL and RC circuit at t is equal to 0 plus and at t is equal to infinite? These things I have already discussed in previous lecture. We will solve some numerical based on this. Okay, and in third categories we have put those circuit which are having sources, and we have to find the response for t greater than 0 up to infinite condition. So in today's lecture we will discuss source free RL circuit only. Okay, let's look how the RL circuit will behave when you remove the sources. So I am removing the sources at t is equal to 0. That means for t less than 0 the network is in steady state, means the inductor is fully charged and the current flowing through inductor will be maximum and it is constant. So for t less than 0 the network is at steady state. After that we remove the sources at t is equal to 0. Now what will happen, the energy present in inductor will dissipated across the resistor and the current will decay exponentially, whose equation is given by it is equal to I naught e to the power minus t upon tau. Okay, this is the transient state, and at steady state you will get zero current or zero energy present in the network because source has been removed at t is equal to 0. Got it? These things we have discussed in previous lecture. If you guys are having any problem, then go to that lecture and study from there. Today's lecture we will solve some numerical based on source free RL circuit. Okay, so before proceeding we should know the step how to proceed with source free RL circuit. Okay, in any kind of source free RL circuit we will make three circuit. Okay, first, second and third circuit. We will make first circuit at t is equal to 0 minus. In this circuit we know that network is at steady state, so we will replace inductor with short circuit and find the inductor current IL of 0 minus. Got it? We have already discussed why inductor behave like a short circuit at a steady state in previous lecture. Okay, after that we will make another circuit at t is equal to 0 plus, at which source has been removed, means at this time at t is equal to 0 plus inductor will have maximum energy stored in it and it won't allow sudden change in current. So that means at t is equal to 0 plus, IL of 0 plus must be equal to IL of 0 minus. This we have discussed in previous lecture. So what I will do, I will replace the inductor with current source. Okay, so at t greater than 0, what I will do, I will make an equivalent circuit, which we have discussed in previous lecture how to make the equivalent circuit. Like we place an inductor in parallel with one current source, okay, having maximum current, and we will make all the circuit according to that, and finally we will find it, that will be the exponentially decaying function, that is equal to I naught e to the power minus t upon tau, according to this graph we have seen earlier. Okay, so these three circuit we will make in any source free RL network in order to find the transient behavior or any response at any state. Got it? So before going to the numerical part, first I will discuss the how to find the time constant of RL network. Okay, for finding the time constant, first what I have to do, I have to short circuit the voltage source and open circuit the current source. Okay, after that we will find that point at which the resistor and inductor are separable, like this point. At this point what I will do, I will short circuit the voltage source, and at this point we can easily see that resistance and inductance are separable. Similarly we will open this circuit, okay, and we will find that point at which inductor and resistor are separable. At right hand side you are getting only inductor, and at LHS side you are getting only resistor. That means inductor and resistor are separable at this point. Similarly we will short this circuit and we will find that point at which inductor and resistor are separable. See, at RHS side only inductor are present, and at LHS side only resistor are present. Okay, now after finding the point, we know the time constant is given by L upon R. So if more number of inductor and resistor are present, then time constant is given by L equivalent upon R equivalent. Okay, so what I will do, I will find the equivalent resistance and inductance from this point. Okay, so when I will find the equivalent inductance, there is only one inductance, so L equivalent will be 1 and R equivalent will be 1 parallel with 1, that is equal to 0.5. So time constant is equal to L upon R, that is 1 by 0.5, that is equal to 2 seconds. See, in this case there is current source present, so it is open circuited. Since this is open circuited, that means this resistor is of no use, so overall the circuit will look like, and we will find the L equivalent and R equivalent at this point. So I will get L is equal to 1 Henry and R is equal to 1 Henry, that means 1 by 1, that is equal to 1 second. See, in this we will replace first the voltage source by short circuiting. After that we will find the R equivalent. R equivalent is given by 2 parallel with 9 plus 2, that means 18 by 11 plus 2, that is the R equivalent. Similarly L equivalent will be 2 parallel with 2, 1 plus 1, that is equal to 2. So time constant is given by L equivalent upon R equivalent, we can easily find. So in these all three circuit we have seen that inductor and resistor are separable. What will happen if the inductor and resistor are not separable? Then how to find the time constant? Then in that circuit we will go with the Laplace transform approach. We will see some problem in which inductor and resistor are not separable, and then how to find the time constant of that network. Okay, now let's move to first problem. See this arrow. This arrow denotes that at t is equal to 0, this switch is opened. This is like this. Okay, so at t is equal to 0, this switch is open. That means what? This is a source free circuit, and at t less than 0, when this switch is closed, that means the network is at a steady state. What I have to do? I will make 3 circuit at t is equal to 0 minus, at t is equal to 0 plus, and at t greater than 0. After that, whatever we have to find, we will go to that circuit and we will find. Okay, we have to find the IL of 0 plus, V of 0 plus, and IL of t for t greater than 0. Okay, so we have to see whether the network is source free or with sources. So we have seen here at t is equal to 0 this sources gets removed, that means this network is source free network. So what I will do, I will make three circuit at t is equal to 0 minus, at t is equal to 0 plus, and at t greater than 0. So we know that at t is equal to 0 minus this source is already connected, that means this network is at a steady state. So at t is equal to 0 minus network is at a steady state. And what we have seen, at a steady state the inductor can be replaced by short circuit. Okay, so first draw this circuit. So this is my circuit at t is equal to 0 minus. At t is equal to 0 minus the source is connected, that means this network is at a steady state, and in any steady state network the inductor can be replaced by short circuit. We replace the inductor by short circuit. This is my circuit for t is equal to 0 minus. Now draw the circuit for t is equal to 0 plus. What I told you, at t is equal to 0 plus this inductor will have, see this, at t is equal to 0 plus this inductor won't allow sudden change in current, that means this inductor will have maximum energy and it will have maximum current. Okay, so we can replace that inductor by current source having maximum current I naught. Got it? So first draw the circuit at t is equal to 0 plus. So this is the circuit at t is equal to 0 plus, in which what I am doing, since this inductor is fully charged, so we will replace this inductor by one current source having same direction as the previous one, and we name it is IL of 0 plus. Got it? So this is the circuit network for t is equal to 0 plus. Why we are representing this inductor in the form of current source? This we have discussed in previous lecture, how the inductor behaves like a current source. Since we are talking about t is equal to 0 plus only, we are not talking about t greater than 0. We are talking about t is equal to 0 plus only. That means this inductor will not decay at t is equal to 0 plus. For t greater than 0, this inductor will dissipate whole energy across the resistor, but at t is equal to 0 plus, it will not decay because inductor won't allow sudden change in current. So at t is equal to 0 minus whatever I will get current, that will be equal to at t is equal to 0 plus. So we can replace this inductor with one current source which is constant at t is equal to 0 plus. It is not decaying at t is equal to 0 plus. Remember this point. Now draw the circuit for t greater than 0. At t greater than 0, what I have said to you, replace inductor by its equivalent. So this is the circuit for t greater than 0, and in this we can easily say that for t greater than 0, whatever the energy present in the inductor will get dissipated across this resistor, and the current will be exponentially decaying in nature, whose equation is given by it is equal to I naught e to the power minus t upon tau. So we have drawn all the three circuit which are present in three cases. Now we will find the response one by one. Okay, we have to find what? IL of 0 plus, V of 0 plus, and IL of t for t greater than 0. Now let us see what is happening at t is equal to 0 minus. At t is equal to 0 minus, inductor should be replaced by short circuited because it is at a steady state. So we will find this IL of 0 minus. Clearly we can say that this 24 volt is in parallel with 40 ohm and 10 ohm. So IL of 0 minus is given by parallel voltage, that is equal to 24 by 10, that is the resistance across this, that is equal to 2.4 ampere. So IL of 0 minus I am getting 2.4 ampere. And also we know that inductor won't allow sudden change in current, means IL of 0 minus must be equal to IL of 0 plus, that we have seen in previous lecture how I am getting IL of 0 minus is equal to IL of 0 plus. Means at t is equal to 0 plus, this current source, this inductor can be replaced by current source, have value equal to 2.4 ampere. So IL of 0 plus is equal to 2.4 ampere. Okay, now we have to find V of 0 plus. Where is V? Sorry, this is V. We have to find at t is equal to 0 plus, we are drawing this circuit, means this V is nothing but V of 0 plus only. So find the voltage across 40 ohm resistor at t is equal to 0 plus. What you will get? V of 0 plus is nothing but this current source is in series with this 40 ohm and 10 ohm, since source is removed. Okay, so this current source is in series with 40 ohm and 10 ohm, that means 2.4 ampere current is flowing through this resistor. Okay, so V of 0 plus will be, see the polarity of this is from minus to plus, that is minus 40 multiplied by 2.4, that is equal to 96 volt in negative. Why I am considering this as a negative? Because the direction of current is from downward, down to up, and the polarity of V of 0 plus is given like this, and we know that in any passive element the current always flow from positive to negative. Since the direction of voltage is given opposite to the original voltage, that's why I am taking negative. So we found V of 0 plus, that is equal to minus 96 volt, and IL of 0 plus, that is equal to 2.4 ampere. Now we have to find the IL of t for t greater than equal to 0. For this I will use this circuit. For t greater than 0 I will use this circuit, and I have to find IL of t. So I already explained you, since the inductor will have maximum energy stored, so all the energy will get dissipated across the resistor for t greater than 0. So IL of t is equal to I naught e to the power minus t upon tau, and we have seen here that this inductor and resistor are separable, and this inductor have value 5 Henry. So and I naught is equal to 2.4 ampere. I naught is the maximum value, and maximum value we are getting 2.4 ampere. So IL of t is equal to I naught, that is equal to 2.4 e to the power minus t upon tau, where time constant, tau is the time constant, and tau can be given by L equivalent by R equivalent. We will find the some point at which inductor and resistor are separable. So this is the point at which inductor and resistor are separable. So L equivalent will be 5 Henry and R equivalent will be 50. So I will get time constant is equal to 0.1. So finally IL of t is equal to 2.4 e to the power minus t upon 0.1. Got it? In this way we will solve any kind of RL circuit by drawing the circuit in three cases: at t is equal to 0 minus, at t is equal to 0 plus, and at t greater than 0. Okay, we will make this all circuit. After that, whatever we have to find, we will go to that circuit and we will find easily. Okay, here I want to discuss one more point. Suppose you have to find VL of t for t greater than 0, means you have to find the voltage across inductor for t greater than 0. So we know that VL of t is equal to L di by dt. Okay, and L is the 5, di by dt we have already find it, d by dt of I naught, that is equal to 2.4 e to the power minus 10t. Okay, so if I will differentiate this, I will get 120 in negative e to the power minus 10t. Why we are getting voltage negative? This is my question. Why the voltage across inductor we are getting negative? This we have already discussed in my previous lecture, why the voltage across inductor will be negative. See, for t greater than 0, the inductor is fully charged and all the inductor will dissipate its energy across the resistor. That means for t greater than 0, this inductor is behaving like an active element. Initially when it was charging, the polarity of voltage was plus to minus, but when it will deliver the energy to the resistor, then the polarity of this inductor will be from minus to plus, because this inductor will behave like an active element. So voltage across the inductor will be negative. Got it? If you want to understand this, then refer my previous lecture. You will understand why the voltage across inductor will be negative. Let's move to the second question. In the second question, we have to find IL of 0 plus, V of 0 plus and IL of t for t greater than equal to 0. First see whether this circuit is source free circuit or not. This arrow means that this switch is opened at t is equal to 0. Means for t greater than 0, we don't have any source present in the network. So this circuit is source free circuit. Now what are the steps required to find any response at any state? We have to make the 3 circuit at t is equal to 0 minus, at t is equal to 0 plus and at t greater than 0. We will make these 3 circuit and whatever we have to find, we will find by approaching to that circuit. So I already explained you at t is equal to 0 minus, this network is at a steady state. That means the inductor can be replaced by short circuit. So let us draw the circuit for t less t is equal to 0 minus. So this is the circuit for t is equal to 0 minus. In this circuit, inductor will be replaced by short circuit because it is at a steady state. Now find current flowing through this inductor. See, this current source will have short circuit path. So no current will flow across 30 ohm and 20 ohm. So IL of, this is my inductor current because inductor is placed here. So IL of 0 minus I will get, that is equal to 2 ampere only. Okay, now draw the circuit at t is equal to 0 plus. We already explained you at t is equal to 0 plus the inductor will behave like a current source. Why? Because it will store maximum energy and the current is maximum. So at t is equal to 0 plus it will not dissipate energy. So we can replace the inductor by one current source. So this is the circuit at t is equal to 0 plus. Since at t is equal to 0, the source has been removed from the circuit. So I will get only this much of circuit at t is equal to 0 plus. And we know that inductor won't allow sudden change in current. That means IL of 0 minus must be equal to IL of 0 plus, that is equal to 2 ampere. And this will behave like an 2 ampere current source. So we have already find IL of 0 plus, that is equal to 2 ampere. Now we have to find the V of 0 plus. So we will go to that circuit which is drawn at t is equal to 0 plus. So V of, in order to find the V of 0 plus, what will be the V of 0 plus? This is the V of 0 plus. So V of 0 plus will be, see this current is flowing like this, and in passive element the voltage drop across it will be such that the current will enter from the positive and leaves from the negative. So polarity of voltage will be same as the polarity that is given. So V of 0 plus is equal to, this resistance have value 20. So 20 multiplied by current, that is equal to 2. So finally I will get 40 volt. So V of 0 plus is 40 volt. Now I will draw the circuit for t greater than 0. I already explained you for t greater than 0 you have to replace the inductor by its equivalent circuit. So we replace the inductor by its equivalent circuit, and in this circuit we can easily say that the energy present in the inductor will get dissipated across the resistor, and at a steady state the energy present in the network will be 0, and the current flowing in this circuit will be exponentially decaying function, that is given by IL of t is equal to I naught e to the power minus t upon tau. Since I naught is given, that is equal to maximum current to e to the power minus t upon tau. Now in order to find the time constant, we can separate this circuit such that inductor and resistor both are separable. So we can find the time constant. At this point you will get L equivalent, that is inductor is having 4 Henry. So 4 upon R equivalent is 20, that is equal to 1 by 5. So finally IL of t is equal to 2 e to the power minus 5t. Got it? Now find the voltage across inductor. Voltage of across inductor is given by VL is equal to L di by dt. When you will find the voltage across this inductor, you will get minus 40 e to the power minus 5t. Differentiate this inductor current, you will get this much. Here also you are getting inductor voltage in negative direction. Why? Because for t greater than 0, this inductor will behave like an active element and all the energy present in the inductor will get dissipated across the resistor. Hence the polarity of voltage get reversed. In this way you can find the response of RL circuit at any state. You have to make the 3 circuit at t is equal to 0 minus, at t is equal to 0 plus and at t greater than 0. After that you can easily find anything. Okay, let's see this circuit. In this circuit, switch is at position 1 for long time, means this switch is connected at position 1 for long time. So this clearly indicates that the network is at steady state when the switch is connected at 1. For long time is nothing but at a steady state. Okay, after that it is moved to position 2 at t is equal to 0. At t is equal to 0, this switch is moved to position 2. So when the switch is moved from position 1 to 2, then this circuit will be source free circuit. Source has been removed. So this is the case of source free circuit. And in any source free circuit, we have to make the 3 circuit at t is equal to 0 minus, at t is equal to 0 plus and at t greater than 0. After that we will find whatever the requirement will be. So first make the circuit at t is equal to 0 minus. At t is equal to 0 minus, this network is at steady state, means we can replace this inductor by short circuit. So this is the circuit for t is equal to 0 minus. We can easily find IL of 0 minus since 5 ampere current source is connected parallel with 8 ohm and this 2 ohm. So we will apply current division rule in order to find the IL of 0 minus, that is given by 5 total current multiplied by the resistance of other branch, that is equal to 8 divided by 10. You will get IL of 0 minus is equal to 4 ampere and that is equal to IL of 0 plus. Why? Because inductor won't allow sudden change in current. So now make at t is equal to 0 plus. At t is equal to 0 plus, inductor will be replaced by one current source. So at t is equal to 0 plus, the circuit will be like this. Inductor can be replaced by one current source having maximum current 4 ampere and this is V of 0 plus. So we can easily find V of 0 plus. V of 0 plus is given by this 4 ampere current will flow like this, like this, like this. So current will enter from the plus and leaves from minus, and in any passive element current always enter from the plus and leaves from the minus. So V of 0 plus will be positive, that is given by 2 multiplied by 4, that is equal to 8 volt. Okay, now make at t greater than 0. At t greater than 0, what I will do? I will replace inductor by its equivalent circuit. Now you can easily understand that this is source free circuit and inductor has maximum energy stored. So for t greater than 0, this whole energy will get dissipated across the resistor. So the decaying equation of current will be IL of t is equal to, this is my IL of t. IL of t is equal to I naught e to the power minus t upon tau. This is the decaying, exponentially decaying current. So at a steady state, the energy present in the network will be 0. What is I naught? 4 e to the power minus t upon tau. Now in order to find the time constant, you have to separate the resistor and inductor. So this is the point at which we can separate. So L equivalent will be 3, R equivalent will be 14. So finally IL of t is equal to 4 e to the power minus 14 t upon 3. This is the answer. Let's see this problem. This has been asked in GATE 1998. What is saying, in the circuit shown in figure, it is desired to have a constant DC current IT through an ideal inductor. Okay, the nature of voltage source VT must be, means which type of voltage source we apply so that we will get IT is equal to constant DC current, that is like this. Okay, this is nothing but unit step function. Okay, we have to give the supply such that the IT will be unit step function. So this Vt is connected parallel with inductor, so Vt is equal to VL is equal to L di by dt. Okay, and we know that it must have unit step function, so L d by dt of ut, and we know that differentiation of unit step function is nothing but del t. So if we will give impulse voltage, then we will get unit step, that is the constant DC current. So option C is correct. Let's look at this problem. This has been asked in GATE 2005. We have to find the current through an inductor at t is equal to 0 plus. See, at t is equal to 0, this switch is closed. Okay, means before t, at t is equal to 0 minus, this switch is open and this 10 volt source is connected with RL network, means this is at a steady state, right? The network is at a steady state. Why? Because this 10 volt source is connected to this whole circuit and switch is open for t is equal to 0 minus. So let us make this circuit. At t is equal to 0 minus, the network is at a steady state, means this inductor can be replaced by short circuit, and we can easily find IL of 0 minus. IL of 0 minus is given by is equal to 10 by 10, that is equal to 1 ampere, and we know that inductor won't allow sudden change in current, that means that is equal to IL of 0 plus. Now draw the circuit at t is equal to 0 plus. At t is equal to 0 plus, this inductor can be replaced by one current source. Okay, now this source is connected. This inductor can be replaced by one current source whose value is equal to 1 ampere. Okay, and this wire is shorted at t is equal to 0 plus. This switch is closed, means wire is shorted. Now see, this inductor is not getting any path to discharge, also it is connected to the source also, so this inductor current will move like this and it will not discharge because it is not getting any resistance in his path. So at t is equal to 0 plus, the current through an inductor will be 1 ampere. Okay, now tell me what will be the current flowing in inductor at t is equal to infinite. At t is equal to infinite also you will get 1 ampere of current, because source has not been removed, source is already present there and we are not getting any resistance across the path of inductor current, so it will not discharge for t is equal to infinite also. Got it? So the correct answer would be 1 ampere. Now see this circuit, this is also asked in GATE 2005. In this circuit what is saying, switch is moved from 1 to 2 at t is equal to 0 plus. Okay, that means before t is equal to 0, that is for t less than 0, this is connected, this switch is connected to 1 and source is connected, means this circuit is at a steady state. Okay, if at t is equal to 0 plus, the voltage across the coil is 120 volt. It is saying at t is equal to 0 plus, the voltage across this coil is 120 volt for t is equal to 0 plus. Then the value of R is equal to what? In any source free RL circuit, you have to draw the 3 circuit in 3 state: at t is equal to 0 minus, at t is equal to 0 plus, and at t greater than 0 if required. If the question is saying that you have to find any response for t greater than 0 also, then you have to draw the circuit for t greater than 0. First I will make the circuit at t is equal to 0 minus. At t is equal to 0 minus, this switch is connected to point number 1 and the network is at a steady state. Okay, so I will make the circuit like this. An inductor can be replaced by short circuited. At a steady state, the inductor is replaced by short circuited. This resistor having 40 ohm, this is 20 ohm. Now find IL of 0 minus. IL of 0 minus is given by total voltage that is equal to 120 by 20 plus 40 that is equal to 62 ampere, and we know that inductor won't allow sudden change in current, so IL of 0 plus is equal to IL of 0 minus. Now make the circuit for t is equal to 0 plus. At t is equal to 0, what is happening? We are switching this switch from 1 to 2. That means we switch this from position 1 to 2, in which this R is connected, this 20 ohm is connected, and we know that at t is equal to 0 plus, inductor can be replaced by one current source having value IL of 0 plus is equal to 2 ampere, and with this 40 ohm resistor is connected. Also in question it is said that the voltage across the coil is 120 volt, means what is coil? This hole is the coil, so voltage across this will be 120 volt at t is equal to 0 plus, and we have to find the R. See, this 20 plus R is connected parallel with this 120 volt, means the voltage across this 20 plus R will be 120 volt, and the current flowing in this circuit will be 2 ampere. So V upon I is given by 20 plus R. So hence 20 plus R is equal to 120 by 2, that is equal to 60, hence R is equal to 4 ohm, 40 ohm. Okay. Now see the second question. What will be the time taken for 95% of stored energy to be dissipated? Okay, at t greater than 0, this network will be like this. Inductor can be replaced by 1 by its equivalent circuit, and this will be like this. For t greater than 0, equivalent circuit will be like this. This R having value 40 ohm. Now find IL of t. IL of t is equal to I naught. I naught is the 2 ampere, 2 e to the power minus t upon tau. Tau is the L equivalent upon R equivalent. L is the 10 Henry and R is the 100. So overall I will get L upon R, that is equal to e to the power minus 10t. Okay. Now see the second question. We have to find the time taken for 95% of its stored energy to be dissipated. What is the energy? What is the value of energy? W is equal to 1 by 2 half Li square. Okay. Now tell me, what is the energy present at initial state? At initial state, the energy present is equal to 1 by 2 into L into current, that is the maximum current is 2 ampere. So 4, that is equal to 20 joule. When inductor is not discharged, then the energy present across inductor will be 20 joule. Now the question is saying 95% of energy stored is get dissipated across this resistor. So how much energy is left? Only 5% energy is left, means 5% of total energy, that is equal to 0.05 by 5, that is equal to 1 joule. 1 joule is left. Okay, that is equal to half L I F square, that is the final current. When 95% of energy get dissipated, then at that time what is the value of current in inductor? That is the IF. If I will find IF, then I can easily find the time taken for 95% of stored energy. IF is nothing but IL of t at that time. Okay, so IF is equal to 2 by 10 under root, that is equal to under root 1 by 5. Now put IL of t is equal to under root 1 by 5 is equal to 2 e to the power minus 10t. You will get t is equal to 0.15 second. Okay, so option B is correct. This has been asked in GATE 2005 for 4 marks. Now see this circuit. In this circuit, what is saying, for the circuit shown in figure, choose R1, R2 and L such that V0 of T will be this much and the current I1 never exceeds 1 ampere. This I1 current never exceeds 1 ampere and we have to choose the value of R1, R2, L such that V0 of T must be equal to this much. So first see that whether the network is source free or not. See, at t is equal to 0, I am removing these sources because switch is moved from this point to this point. So overall the sources has been removed. So this is a source free circuit. Okay. Now what you have to do? You have to draw the circuit at t is equal to 0 minus, at t is equal to 0 plus, and at t greater than 0. You have to draw these three circuit. First draw at t is equal to 0 minus. At t is equal to 0 minus, this network is at steady state, so inductor can be replaced by short circuit. So this is 10 volt, this is R1 and this is inductor which is replaced by short circuit. Now find IL of 0 minus. IL of 0 minus is equal to 10 upon R1 and that is the maximum current flowing through this inductor, and in this question it is said that I1 never exceed 1 ampere, means IL of 0 minus must be equal to 1 ampere. It must not be greater than 1 ampere according to question. So from here we can find R1 is equal to 10 ohm. Okay. Now draw the circuit at t is equal to 0 plus. At t is equal to 0 plus, this inductor will be replaced by current source having value I of 0 plus, that is equal to I of 0 minus equal to 1 ampere. Okay, and this is connected with R2 and R2 having V0 of t this much. Now see this equation, if I will put at t is equal to 0 here, then I will get V0 of t is equal to minus 20, means V0 of t is equal to 0 plus is nothing but minus 20. Now see this, if I will find the voltage across R2, that I will get minus 1 ampere current multiplied by R2, hence R2 is equal to 20 ohm. Got it? So we find R2 is equal to 20 ohm, R1 is equal to 10 ohm. Now we have to find the inductor value. Okay, so for finding the inductor value, no need to draw the circuit for t greater than 0. We will see the time constant. Here time constant is 1 by 10 to the power 6, that is equal to L upon R. Hence L is equal to L upon R2, since R2 is connected, so L upon R2. Hence the value of inductor will be R2 upon 10 to the power 6 and R2 is 20, so we can easily say 20 micro Henry is the value of inductor. Now see the last question. We have to find I1t and I2t for t greater than 0. Okay, so finding the response for t greater than 0, we have to see the circuit for t less than 0 as well as t is equal to 0 plus and t greater than 0. Okay, now see this circuit. At t is equal to 0, this switch is closed, means for t less than 0, this switch is open, means this source is connected to both the inductor. So we can say that at t is equal to 0 minus, this network is at a steady state, so we can replace both the inductor by short circuiting. This is 5 ohm, this is 20 ohm. Now we can easily find I1 of 0 minus and I2 of 0 minus, and we have to find the current first, I here. So I is equal to, apply current division rule here, you will get 5 multiplied by 6 by 10, that is equal to 3 ampere. Now I got this I is equal to 3 ampere. So I1 of 0 minus will be 3 multiplied by 20 by 25, that is equal to 2.4, and I2 of 0 minus will be 3 multiplied by 5 by 25, that is equal to 0.6. Okay, now we have to find the current I1 and I2 for t greater than 0. So I have already explained you for t greater than 0 you have to replace the inductor by its equivalent. Okay, now replace this inductor by equivalent, and source has been removed because at t is equal to 0 this switch is closed. So the circuit will look like this. This is the equivalent circuit having 0.6 ampere here and 2.4 ampere here, and these two parallel path is sorted by switch. So here you can easily understand that this inductor current and this inductor current are not interacting each other. These are independent because of this short circuit. The current present in this inductor will not get affected by this, and similarly the inductor present in this will not get affected by this current source. Okay, so finally I can say that I1 of t is equal to, we can separate this circuit. Okay, so I1 of t is equal to 2.4 e to the power minus t upon tau 1, and I2 of t is equal to 0.6 e to the power minus t upon tau 2, where tau 1 can be found by this L upon R. We will not include this because of this short circuited path, both are separated. Okay, so this I will get 2.5 upon R is equal to 5, and tau 2 I will get 4 by 20. In this way we can find the response. Got it? So that's all about the source free RL circuit. We have studied how to find the response of RL circuit at t is equal to 0 minus, at t is equal to 0 plus, and for t greater than 0. So in any source free RL circuit at t is equal to 0 minus, the network is in a steady state. So we can replace that inductor by short circuit and find the IL of 0 minus. Now we know that inductor won't allow sudden change in current, that means IL of 0 minus must be equal to IL of 0 plus. Now I will make the circuit at t is equal to 0 plus, and at t is equal to 0 plus we will replace the inductor by one current source having maximum value IL of 0 plus, that is equal to IL of 0 minus, and we can easily find the response at t is equal to 0 plus. Now I will make the third circuit for t greater than 0, and for t greater than 0 inductor can be replaced by its equivalent circuit, and all the energy present in the inductor will get dissipated across the resistor, and finally at a steady state the energy present in the network will be 0, and the current will decay exponentially given by it is equal to I naught e to the power minus t upon tau. So in this way we can find the response of any source free RL circuit. In the next lecture we will see the response of RC circuit and RLC circuit, that is source free only. Okay, so if you guys are having any problem then you can ask in our Facebook group or put it in the comments below. For new updates please subscribe to this channel. Thanks for watching this video.